All right, everyone. What we are going to have today is just some examples that I took directly off of your last two no reassignments. 9-3 has been assigned because it was strictly for our 45-45-90, our isosceles right triangles. I did put two examples in there already on our 30-60-90 assignment that I said if some of you want to get a jump start on, you absolutely have that capability. So what I want to do is look at some of the later questions that were in our 45-45-90. It didn't have a picture, so I pulled that one specifically. This process can be for both the 45-45-90 and honestly our 30-60-90. So the first thing I'm going to do is I am going to draw out our isosceles right triangle so that I can label it with our formula, and it says that the hypotenuse is 21, so we know that that has to be on this side. Because it's an isosceles right, we know that each of these are 45, so we're going to put our formula in around it, and we have a, and a radical 2. So then what we have to remember is the side that has our formula and the value we set equal to each other. So we are going to take a radical 2 and set it equal to 21. We know we're going to divide away the radical 2 so that we get a by itself. And what we end up with is 21 over radical 2. And again, we talked about this is not appropriate for a final answer. We have to rationalize this, which does mean get a perfect square in the denominator, and our perfect square would come from multiplying, in this case, the prime number by itself. But because we don't want to change the value of this fraction, we're going to multiply by that special number 1, and anything divided by itself is really 1. So again, we'll have multiplying across 21 radical 2 over the square root of 4. And most of us will see the pattern that you have your original numerator, the radical shows up on top, and just the radicand, or the number inside, on the bottom. So it says, what is the length of the leg? So when you get into your no reassignment and it asks you for this, you are going to have to make sure that in that box you access the fraction button, and then in the top you'd have to also not only have 21 but access that radical button. So your final answer is 21 radical 2, and then in the denominator make sure you put 2. So that is our final answer for the legs. Both of these guys would be 21 radical 2 over 2 and 21 radical 2 over 2. So one of the reasons I picked that question was not just so that you draw your own picture and do your own formula, but also to make sure that you recognize that our answers aren't always going to just be whole numbers, and they might not just be something in a radical. It could also be those fractions that we saw before. So make sure you access, when you click in that box, all of the correct symbols. So the next one, you know as well as I do that we would look at this problem and just completely bypass it. We wouldn't even try it. And this actually is probably a little bit easier than even this one up here because of all the rationalizing. What we want to make sure we do is just read, and I kind of left out some, wrote a lot more to this than I did in a couple of the other examples that I copied. But a tanagram has 7 pieces. It specifically says right isosceles, square, and a parallelogram. The idea here is that we do have a square, and it tells us that the area of FGHI, so that square, is 25. So when I look in here, this square has an area of 25. And what we're supposed to remember is that our area formula is really something squared. So side squared equals 25. So what we find out is each of these sides is 5. So everywhere around this, we want to know it's 5. So if this is 5, and this is 5, 5, 5. So all of those pieces and parts are 5. What I want to now point out is not only is this a square, but it says isosceles right triangles. So that means even though I'm not really looking for BFG, BFG is also an isosceles right triangle, which means here's our hypotenuse, but each of these guys has to be the legs. So if that's 5, so is this guy. So now what I know, and I'll highlight this one in orange, when we go and actually try to find the perimeter of BEA, BEA is this triangle. And if this guy was 5 and that guy was 5, over here I'm going to draw BEA, and I'm going to take this and make it 10. And that's because it was 5 plus that other 5 that we had there. Well, again, it's an isosceles right triangle, so that means each of these guys have to be the same measure. They're both 45, which means each of these have to be the same measure. So I had 10 from the other one. We now know that we're going to have a matching 10. And I could either do the Pythagorean theorem or I could use my formula for 45, 45, 90, A, and A radical 2. Well, it obviously matches up that both of these are 10. So that means this one has to be 10 radical 2. So if I want the perimeter of triangle BEA, we're going to add up 10 plus 10 plus 10 radical 2. Now we want a exact answer because it doesn't say round, so make sure you recognize that when you plug this into your Knowre assignment, you need the exact value. And you should be able to type this out exactly, 20 plus, and then 10, and access that radical button and put the 2 in. So our final answer would be exact at 20 plus 10 radical 2. And most everything from this comes from making sure we recognize what's being described in the problem. And draw it out if you have to. Label things, put tick marks in things, that way you know for certain. So that was number 15. I did click on it a couple times and it seems to give us the same information over and over, just might change the values a little bit, so pay attention to that. All right, let's take a look at the last one I have from 9-3. And we have this triangular pyramid. Now it's definitely drawn a lot better in the program, but we did talk about pyramids at the beginning of the year with our volume and surface area. And it does say that the base is an equilateral triangle, but all of the sides that kind of fold up, those are isosceles. And it does tell us specifically that PSC, so P to S to C, that guy right there is going to be a 45, 45, 90. So before I do anything, I'm going to draw PSC separate. And I'm going to label it according to its description in here. And it does say that it's 45, 45, 90, so that means each of these guys have to be congruent, which makes each of these sides the same. And because it's 45, 45, 90, I know that A, and A radical 2 have to be the formula that I use. So the side that has the formula and the value, we're going to set equal to each other. And when we set them equal to each other, A radical 2 equals 8 radical 3. And we know that we have to divide away the radical 2. And we're left with A equals a numerator. Notice that I'm not saying what it is. Don't care how ugly it is. A numerator and radical 2 in the denominator. I am supposed to still rationalize this, which means we're going to multiply top and bottom to make that denominator a perfect square. Our original numerator, our denominator shows up on top. And after we simplify the radical 4, notice we have our numerator, the radical appears on top, and just the radicand in the denominator. I had the same process right here. The numerator, the radical, and just the radicand. So it's the same thing here. The only thing that's going to be different is these two are like terms. We can multiply those two together. So what we end up with is A equals 8 radical 6 over 2. Now the 8 and the 2 can cancel because that 8 divided by 2 gets us 4 radical 6. All right, so we find out that this is 4 radical 6 and this is 4 radical 6, which means from S to C is 4 radical 6. All right, so far, that's just our information on our special rights. It does go on, however, to say if C is a centroid. Now, here's some information from chapters past, and we're supposed to remember that a centroid has a formula because it's that point. So in review, it's the point where medians are concurrent. It's our point of concurrency. We also know that a centroid equals 2/3 the median. And we said that from the vertex to the centroid, compared to our centroid to the midpoint, was a 2-to-1 relationship. So not only did we talk about 2/3, but we did talk about from the centroid to the midpoint was a 1/3. So it's a 2-to-1 relationship. So if I have 4 of something on top, and that's 2 times something, I only want 1 of it down here. So from C to L, that would end up being whatever 4/6 is divided by 2. So CL is 2 radical 6. 2 radical 6 is 1 of something, and 4 radical 6 is our 2 of something. 1 times 2 radical 6, 2 times 2 radical 6. So that goes back to that other chapter. So when we plug in our final answer, it does say find LC, LC is 2 radical 6. And that all comes back to our centroid work from a couple chapters ago. That one I thought was pretty intense. I wanted us to look at it. The radical work wasn't the major issue because it does tell us what triangle to use. We didn't even have to guess. It was the centroid that we had to recall our information on. So I wanted you to have that. All right. So moving on, for those of you that wanted to get a start on your 9-4 work, I wanted to give you an opportunity to look at what I thought were honestly the 2 more involved questions. Pretty much throughout the 21 questions prior to this, they were all, here's the diagram, use the formula. Here's the diagram, use the formula. Or they would have it in words, but it was still the same idea. So in this one, they combine our 45-45-90 and our 30-60-90. So the first thing I'm going to do is I'm going to just deal with that side. I don't even want to look at the other side of this. So I'm going to do this in parts, and I'm going to take this first one, and I'm going to bring this out just to make it easier. And because this is 45, that means this is 45. We have 8. But I don't know what the other 2 sides are. So we're again going to label our sides A, and A radical 2. Side with the value and the formula we set equal to each other. And we end up with A radical 2 equals 8. We know that we have to divide both sides by radical 2. And we end up with A equals 8 over radical 2. And again, we do not want to leave that in the denominator. It is not appropriate. So we're going to rationalize, and that means multiply top and bottom by radical 2. And again, you see the radical appears on top. The perfect square shows up on the bottom. And we end up with 8 radical 2 over 2. And obviously this looks familiar. We just did something like this. So we find out A is 4 radical 2. So that means this is 4 radical 2, and this is 4 radical 2. So from S to L is 4 radical 2, and right here is 4 radical 2. So now we're going to look at this other side. This other side is our 30, 60, 90. And I'm going to redraw this guy over here. And it tells me that that's 60, so that means this is 30. I also found out that one of the side lengths was 4 radical 2. I know that because we just did all that work. So that 4 radical 2 is still right there. Now that I know it's a 30, 60, 90, my formula is going to change. We are going to use a different formula in this. We know opposite the 30 is A, opposite the 60 is A radical 3, and opposite the 90 is 2A. Well, what's nice about this is the side that has the formula and the value we set equal to each other. So we just found out A was 4 radical 2. Well, it's kind of what we said over here, but just to remind us how to do it, which means everywhere I see A, I'm going to plug in 4 radical 2, which makes this 4 radical 6, because those were like terms. 2 times 3 is 6. And if for some reason we'd need to over here, we could plug in 4 radical 2, and this side then becomes 8 radical 2. So that means this piece right here is 4 radical 6. Now the catch is, if we want to figure out what PL is, the only way you can add with radicals is if they were the same. So like if this was 4x and this was 4y, We don't combine them because they're not like terms. We can't add x's and y's together. They're not the same. So it works the same way here. This radical and this radical can't get added together. So when we do the entire length from P all the way to L, our final answer for PL will get plugged in as 4 radical 6 plus 4 radical 2. And you are able to plug in the plus sign and the radicals and everything. So 2 problems in one. The nice part is what we did all the work for over here immediately helped us over here. We just have to remember not to use a decimal. We have to use the exact value. So number 23, I purposely did. I was going to stop, but I didn't like where the 4 radical 2 was sitting. So we're going to look at this real quick. I did not write the whole problem out. I abbreviated. It says that there are firefighters getting ready to enter a building, and they're going to place a 4 radical 2 meter ladder at a 45-degree angle to a 2nd-story window. So that's what this guy is. Another ladder is going to get propped from the same position to a 3rd-story window at a different angle. So they're not telling us what this angle is down here. We want to find the difference in the height of these two. So we want to know what that is. So the difference in the height between the 2 windows. We want to know what M to N is. Well, you can see down here that I changed something because I started working this problem out and I know I had the answer right and it kept coming up wrong, and I realized where they put this 4 radical 2 in the picture, it was kind of floating over here in the middle. I assumed it was this piece here. It's really the hypotenuse. So if you're doing this problem, don't think you're doing something wrong. Maybe you just labeled it incorrectly. The 4 radical 2 is supposed to be on this piece, and it looked like it was closer over here. So that's why I kind of left it like that. So we're going to do 2 problems again. I'm going to draw our 45, 45, 90, which was N, B, C, and they told us that this was 4 radical 2. After I did some work, found out that it was labeled a little weird, but I know opposite is A, and A radical 2. Well, we can see what A is. So we know A is going to be 4. So that means this side is 4 and this side is 4. So I'm going to go into my problem, and I know that this side is 4 and I know this side is 4. So when I redraw my 30 and my 90 degrees here with M, B, C, and we just figured out this side was 4, what I now know is, again, A, opposite our 30 is A, opposite our 60 is A radical 3, and opposite our 90 is 2A. Now, they could have asked us a couple other questions. For instance, if we know that this angle is 60, that means this whole angle, MCB, is 60. So they could have asked us how much that angle was, which would just be 60 minus 45, and we'd know that one. Just saying. So again, we know the side that has the formula and the value we set equal to each other, and again, we've confirmed that A is 4. So that means I'm going to plug that in here, and we end up with 4 radical 3. So this one is 4 radical 3. Well, if I want to find out what the difference in height is, I'm going to subtract. That guy's more because it's got 4 and something. That's just a 4. So when we find the difference in height, what we're able to do, and let me put that all the way down because that's really what it is, from M to B, from M to B. That's this whole height. We want to know how much just that guy is. So when we know that M to B is that whole thing, we want to know how much is just that. So the difference in height would be the 4 radical 3 minus the 4. And again, you will have to plug all that in Knowre in order for you to get that one right. So 2 problems again in one. You saw that the A got repeated, so that worked out really well. And then we just had to recognize that the difference in height meant take the full height that we found, 4 radical 3, subtract that partial height, and that's your exact value answer. Only use the decimal when they tell you to round. So hopefully that helps out if you're doing your Knowre questions. Take your time, email me if you have any questions, take screenshots, and we will talk to you again on Monday.